Hello friends, welcome to online tutorial videos from JCBRO Labs. For more information and to learn more information about us, you can visit us at www.jcbrolabs.org. So this is our second session in live tutorial videos on 8051 microcontrollers. And in today's session, we are going to learn more about 8051 microcontroller, specifically different memory structure and different registers, and then we will do some programming in assembly language. Okay, so let's start. Okay, so prior to starting, let's wait for some students to join. So there are some students who are joining us on regular interval. So let's wait for them for 1 or 2 minutes. Okay. Okay. So till now, Neha Sharma has joined. She is very regular and continue to support us by watching our videos. Uh, Hello, Neha. So if you have any doubt or if you want to share some experience, you can. Right. So let's wait it out. In the meantime, I can discuss with you about the 8051 about the assembly on assembly and other programming languages. So when it comes to the programming of these microcontrollers, so there are two options generally available to every embedded programmer. That is the assembly language or the embedded C language. So what is the core difference? So in basically in assembly language, we directly think about from the hardware perspective. That means from different registers available in on the IC, and we have to keep tracking and at every aspect of it. So that doesn't happen automatically. We as a programmer have to think about it and then have to write a program accordingly. While in the case of this embedded C language, compilers takes care of everything. So we don't have to think much about how those registers are being allocated, how different memory management is being done. So everything is done by the C compiler. And remember, this C compiler is specifically different for each kind of microcontroller, because each microcontroller has different instruction set which are suitable for itself only. So it is not like we can write program for ARM series microcontrollers for 8051, right? So we have to remain cautious about that as well. Okay, now coming to our programming part, right? So let's change the scene. Here comes the programming. So today we in our last class we talked about several things of different that means different some of the basics about addressing, some of the basics about uh, uh, how this conversion takes place and what is the register means and everything. So today we are going to talk about the RAM architecture of this 8051 microcontroller. So basically we start with the RAM architecture. So RAM architecture at its name suggests a random access memory, right? So it is like when program got executed, start executing itself, there are certain variables which are being created in between. So those variables are stored in the RAM, and there's a lot memory. There's a memory which is available to 8051 microcontroller that is of 128 bytes. So wait, some of you will say, okay, no sir, it has total RAM available is 256. Yes, total RAM available to in 8051 is of 256 byte, but it is divided into two portions, 128 bytes and 128 bytes. So you can tell it like a general purpose RAM, and other 128 byte RAM is the special special function RAM. So okay. So a special function means different address of the different registers which are by default, or which register we can access direct just by their names only. Those addresses are available in this special function RAM. While in the general purpose RAM, normal registers and everything's stack addresses are available here, and that can be accessed based on the user request. Okay. So more people has joined us. So just wait a minute. Okay, fine. Okay. So coming back to its structure. So this we are going to talk about this 128 bytes of the general purpose structure, because it is 128 bytes. So if I ask you about the addressing, so if I ask you about the addressing, so 128 bytes means it has 128 different locations. So remember from our last exercise, that means there will be total 8 wires, right? So 8 different wires will be there. Now if we talk about the addressing, so addressing, for addressing you can think of these are the 8 wires, 5, 6 and 7. So for 128, 128th address will be like this one. So it will go from like 120 to 127, right? So this number is the 127, right? So this is your 7 and this is your F. So it starts from this addressing starts from 0x002 and goes up to 0x7F. So I hope now you understand why this 7F is coming, because it is going from 0 to 127, and the hex code corresponding to 127 is 7F, right? Okay. Now in each within this, it is divided into different registers. Okay, so these are the 4 register banks. Okay, I should write register bank, and these are specified as register bank 0, register bank 1, register bank 2 and register bank 3. And each register bank I should have specified contain 8 registers. So yeah, in our last class I talked about one register means it has 1 byte or 8 bits. So one register is of 1 byte. So 8 register means 8 byte, and it horizontal location is like 1 byte location. So similarly there are 8 different registers within the register bank, and those register banks are specified by their name as register 0, register 1, register 2, register 3 and up to register 7. Okay, so addresses will start from 00 to 0x07. So the last address of this register bank 0. Similarly, the next register 8th, it will be 0x08 to 0x. Again add 7 into it, you will come to 0x0f. So keep adding 888 to everything, then you will find the highest register, highest address of this register bank comes out to be 0x1f. So these are the normal register which we can access directly. And remember our last command, as I write like register R0 and hash 15h. So that indicates this 15 number. is stored into the R0 register. Now you know more about this RAM structure. Now you will came to know, okay, which register 0 it goes to, whether of register bank 0, 1, 2 or 3. So obviously there are certain uh, flag bits or certain other registers which are used to specify in which register this in which register bank in which register 0 of register bank this 15 should. Okay, we will come to that later. Apart from that, we comes up with the bit addressable RAM. So bit addressable RAM means each address of this bit can be accessed directly. It is from 20 to 2F, right? So you can think of it as a 32 byte of not 32 byte. It is around, yes, 16 bits of memory is available here. 20 to 2F. That means from here to here, total 16 register. That means 16 bytes are available, and within 16 bytes, each bit can be accessed separately. And we will come about this how to access this each bit. Will come about this later. Then there's a scratch pad memory. So scratch pad means which can be written or removed easily. So this is generally memory is available from 0x30 to 0x7. Okay, so within this scratch pad memory we can store our data at our requirement, or right, or it can be used for general purpose again. So this is the RAM structure of 8051 microcontroller. Now accessing to the different registers associated with this RAM, right? So first we will talk about a program counter, or let's talk about first PSW, that is known as the program status word. So as its name suggests, this PSW specify the status of the program. Okay, so program status word, that means it contains different bits. It is a 8-bit register. Let's say 0, 1, 2, 3, 4, 5, 6 and 7. Yeah, fine. Now these are written as with different names, or these are represented by the different name, right? These things which I am writing, like RS0, RS1, OV overflow, and this parity. So these are known as the flags. So this P stands for parity. This stands for overflow flag. So this overflow flag happens when there is a signed operation, and the result of the signed operation is too large. So this overflow flag gets set, right? Similarly, this RS0 and RS1, these are of important. I will discuss it later. This is F0 is for reserve. Um, okay, and this AC, this is the auxiliary carry flag. Okay, so auxiliary carry flag means if you are doing some operation, addition or multiplication operation. So if there is a carry from this 4th bit to 5th bit, I should say this 3rd bit to 5th bit, that means the carry within the nibble, then this flag got set. Okay, so generally it got set during this add operation or the subtraction operation. Similarly, there is a CY, it is the carry flag. So when carry is generated from the last bit, then this carry flag is set. So there are different small commands which can be used to set or reset, and we will come to those commands later in this online course content. Okay, right. So now coming to the these two bits. So these RS1, RS0 are known as the register select 0, register select 1. So remember here I said, like in which register bank of register 0, or this has to be specified from this RS0 and RS1. So these registers define in which register bank or is active at a time. Okay, so if the value is 0 and 0, So it indicates it will go into register bank 0. If it is 0 and 1, it indicates it will go into register bank 1 1. It is register bank 3, right? So this is about this PSW. Similarly, we have another very useful register, and that is generally is available in all kind of microcontroller, and you should be very much aware about it. That is known as the program counter. So that is very important register, and you should learn about it. You should be aware about this particular counter. So it is a 16-bit counter, 16-bit register, right? So it doesn't do anything. It just contains the address. Okay. So I should say it contains the address. It contains the address of next instruction to be executed. So it is a very important thing. So here is our CPU. It keeps on executing the instruction. So in order to execute the instruction, it will fetch those instructions from somewhere. Okay, here is our flash memory, right? And remember, in our last class I told you where the program is stored. Program is stored into the flash. So whatever we write in the form of instruction, embedded C language, whatever you use, all that program is stored in this memory. So here is the program. So microcontroller fetch the instruction to be executed from here. Okay, now which instruction to be executed, that is specified from this program counter. Okay, so if program counter is 00, then CPU will go to the location at 00, fetch that instruction, execute that instruction, and store the result somewhere else if it is required. It will go to the next instruction. So program counter will become 1. Once this instruction is executed, program counter will become 1. So if you go to the first address, execute it, and it will do some other task. So now you can think of, like, if we do, or if we tinker with the program counter addresses, our entire program can collapse. Let's say if within the program I change the status of or value of this program counter to 0xff, and if nothing is being stored there, then CPU will not do anything, right? And it will, our program will crash. Okay, so that is why this program counter is very important registers which needs to be taken care of, and you must know the address stored in this program which will be executed from the CPU. Okay, and we will learn more about it during the loops, right, or during other statements as well, because this program counter, these instructions also written in such a way that they change the addresses of the program counter accordingly. Okay, now there's another thing, that is the stack. You may have heard about the stack more often in different programming languages, either in the data structure in C and uh, in other languages as well. Okay, so there are many students have joined us, so let's tell them hello. So if any one of you have any doubt, then you can ask by typing your query during this live chat, and then I will try to answer that query. Okay, so now we were talking about this stack. So stacks are a collection of memory addresses, right? A collection of memory. So it is generally used to store sometimes data within the memory. So you must have heard about stack is a kind of thing, a table on which on top of it you keep on putting your files. So that become a stack, and from where this name is coming up. So stack is a collection of memory. That means if we specify certain range of the memory, that becomes a stack. Now this stack is accessed by this data or this register that is known as the SP, or it is known as the stack pointer. Now if coming back to the earlier RAM structure, so I talked about this other 128 byte of RAM, right? This was a special function RAM, and I told you like different registers are stored here. So what are those registers? Like PSW. So this PSW is being allocated some memory location within this RAM. Similarly, this stack pointer. So this stack pointer is also available in this RAM, because this stack pointer, I said, it is a register. Again, this is a register, and let me verify whether it is of 8-bit, or because it can go within the RAM, so it is of 8-bit register only, right? So 8-bit means it contains the address of the memory, right? So when we talk about the stack pointer, so this is the address of memory location. So right, it is not the data. And again, this SP is also available at some location within this special function RAM, and address of entire RAM can be stored in this. It is 8-bit, and similarly our memory ranges also goes from this 0x00 to 0x7. So by default, when our controller or our microcontroller just boots up, right? So starting value of this SP is, that means the content within this XP is 0x07. So I will be using the arrow to indicate it. That means it indicates the stack pointer here. And remember, this 0x07, it lies in the address of the register bank 0, right? So that means all memory location above it, they can be used as a stack to store the memory temporarily within the program. So how this I will repeat itself. At the starting, the register content which is in this stack register, that content is 0x07, and as I indicate, this content of this SP is the memory address. So that means this is the memory address of the last location of the register bank 0. And as programs, we require this stack pointer can point to any other memory location. That is up to us to which memory location we want to point it to. Okay, so all other memory can be used as a stack. So if someone asks you from where the stack begins, you can say stack begins from the address location of 0x08. That means the register 0 upwards. Now there are instruction. Those are the instruction push and pull instructions which are used for this stack operation. So push means it increment the SP stack pointer by 1 and then locate the content to that location, right? So whatever, let's say I want to store 05, so it will increment the stack pointer. Now stack pointer will point to the next location, and then 05 will store there. Okay, similarly and so on. So similarly, pull first reduce the stack pointer by 1, and then it first retrieve the data and then reduces the stack pointer by 1. So now you can think of this register bank 1 coincides with the register 0 of register bank 1, coincides with this stack pointer, right? Okay, coincides with this stack pointer. So that means there's a clash between these stack pointers. So this is a general practice to change the content of the stack pointer if we are going to use as soon as we start the program to the memory available within this range from 0 at memory. So we can shift this stack pointer to here or to another location of here, and from here we can specify, okay, this range of memory is acting as a stack, and we can use then it accordingly. But now when we are writing this entire program in assembly language, we have to keep track of each aspect, what is the content of the stack pointer after every instruction, right? Because as I said, in this assembly language, compiler is not going to do anything. We have to optimize each and everything, right? And that can be only done once we keep on checking it. Okay, now coming to some programming. So today we have talked about this register banks and this stack. So we will write a simple program first. So we will select different register of different that means different registers of different register banks, and we will try to manipulate their content, and then we will do some additions, operations, etc. Okay, so and we will demonstrate you with the help of a proper programming. So till now, if any one of you have any query or any doubt, then you can let me know. Okay, let's wait for some time. I am opening. Hmm. Okay. Okay, someone is saying there is a glitch in the mic. Actually, Nikunjo, it is due to the fact that this software automatically reduces the sound when I'm not speaking, so that no other noise comes in between. Okay. Okay, coming to the program, let's change to screen through to the programming. So this is our KEIL. So we talked about a little in earlier session about the KEIL, right? Okay. Okay. So let's start with this KEIL. We will create a new project. So go to project, new microvision project, and then we will go to the location where we stored all our sessions. Okay, online tutorials. So we created a program here, so that is the first program which we'll create. We will be checking the register banks here. Okay, so we'll select atmel 89s51 at 89s51. Okay, yes. Okay, let me check. I forgot to create a new register. Yeah, that's what the problem is. So let me close it, and okay, let me adjust the settings. So this program again started because I forget to put into the register, okay, in a common folder. Okay, so creating a new file. So we are using this assembly language programming, so we have to choose the assembly. Okay, that is not coming up here, so I will share the screen. uh, Not this one. Add source here. From here you can this small window opens up, and here you can set this assembly files, and then you can put the name of this assembly file, that is like main.asm. So you can also save the file either by .asm or a51. Okay, here. So we will start writing a program, and we can set to the different operations. So we'll go to options for target one. A different window will open then. Okay, so each time this window is opening up, I have to select that window. Okay, so here it is. So here in this window you can choose different options like frequency. So let's select 11.0592, and output we can choose this hex file. Okay. So why I'm using this hex file, because in this theory classes, as we progress, we will be interfacing different peripherals, and we'll be writing the programs for them, and then we'll simulating all those program in Proteus as well. Okay, so making it okay. Yes. So as I said, we start with org 00h. So it is specified like at this memory location the program will start working. Okay. Now here in the command we can also put the comment here as well. So we are sending data to R0 comma hash 51h. So this 51 hexadecimal value will go to register bank 0, right? R0 register bank 0, and then I want to change the move the data to register 0 of register bank 1, right? So I will first change. Remember this PSW bits RS0 and RS1 in order to change. So in order to change this register content, we have to change this RS0 and RS1, right? So we have to make, in order to select the register bank, we have to make RS0 set and RS1 reset. Okay, so now we want to go into the store data into register bank 1. So we have to set this RS0 bit of the microcontroller, and this RS0 bit is third bit of this PSW register, right? So we'll set bit. So this is the command which sets the any specific bit of any register. So we'll type PSW.3, and then we will write like selecting register bank 1. Okay, now let's check. I am having some doubt whether it will throw an error or not. Let's compile it. Okay, okay, we got 0 error, right? Now we will type again move R0 comma hash the same content. So now this data goes to register bank 1, right? Now we add some data, because remember right now register bank 1 is selected. We add some data, so add a comma. Okay, first of all we move the content of R1. So move R1 again in the register bank 0. We will move R1 10h, and then we will add okay, move a comma R1, and then we will add a comma R0. So remember all this operation is happening on the register bank 1, and then we will send this data move to the register 0 of register bank 2. Okay, So set bit. So in order to make it uh, in order to clear this bit, we have to use some other bytes, other bit as well. So in order to select this register bank 2, we have to set this PS1 and then clear one more bit of this register bank. That means we have to clear PS.W.3 and we have to set PSW.4. Now I forget the command related to the clearing, so just hold on a minute. Generally that happens. Let me check. Fortunately I have book along with me, so that is CLR or CL something, but let me confirm it. Yeah, CLR, clear bit. Okay, so we will first CLR PSW.3 and then set bit PSW.4. So by doing this, we are selecting the register bank 2, right? And then we will move the accumulator content to R0A. So this content A goes to the register bank 2, right? And then we will keep on jumping here. So here DJNZ, not DJNZ, it was because DJNZ stands for decrement and jump, so we will use SJMP. It will remain here SJMP here and then so let's compile it. We'll throw an error if there is any. So right now there is no error. So now let's go to the debug session. Okay, so now we will execute this one by one and we'll seeing the data of this one. So we have program counter, stack pointer, PSW, everything is available, right? Okay, now let's see the code memory as well. Memory 1 0x C. Remember I told you if you type like C, it is the code memory. Okay, 0x00. Okay, so this in the code, and then we will see the data memory as well. Memory window, again memory 2. So code memory, the hexadecimal codes of these numbers are these, and we'll go to data memory. So D0x00. Here is our data memory. Okay, so we will execute it first. So move R0. So remember, if we are starting with 00, move R0, register RAM of the register. So at this 51 should come up. Okay, 51 has been here, and similarly R0 has been updated. Now we have set the bit of PSW.3. Now the R0 content, remember, see, look at the content of this registers. It has become 00 because now it is showing the registers of the register bank 1. So register bank 1 starts with 0 1 2 3 4 5 6 7 from this location. So this 51 will go here, so we will do, yeah, and similarly register bank 1, it will go here. Yeah, it has become 10. So I hope you are following with me. Okay, now coming to the next instruction, move A, so it will go to the accumulator. So if we look about the registers of the special functions, okay, those registers and everything has a register. So if you go to the data sheet of this 8051 microcontroller, then you will find these registers as well. So if we talk about this ACC, so it is in F8 location, right? So let's execute it. So F8 location is this, somewhere around here, right? It has moved to the accumulator, and then we will move the accumulator. We'll add the content of accumulator with the content of R0. So right now accumulator is 10. Now after adding operation, it will become 60. Now by clearing this PSW point 3 and setting this PSW point 4, we are selecting register bank 2. So now register bank 2, all the content has become 0, 0. Okay, so register bank 2 starts from 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, from here. So this is the register 0 of register bank 2. So the content accumulator content 61 should appear at this location, here 61. Okay, so now it will keep on jumping here only. So it is a kind of a while loop, as we discussed. So this is how you can track each and every memory bit available to you in the IC. Okay, and through this assembly language program. That is why it is very generally very big programs, or in which we have very constraints about the memory. We are very much I should say concerned about the memory. Then we write program in the assembly language, and this assembly language codes, like these are the codes for 8051 only, first of all, and similar codes or the mnemonics are provided by the each microcontroller manufacturer. Even your P4 or Core i3 processors also have this kind of mnemonics, because ultimately microcontroller or microprocessor understand only the a digital language. That means it is not like they can understand our high level programming. Everything has to come down to the hex codes. Okay, so this is about very interesting and very small introduction of this assembly language program within this entire tutorial series. So I hope you enjoyed it and you understand something. You got better understanding about the very basic programming of these microcontrollers, especially these 8051 microcontrollers. So if you have any doubt or any query, then we will wait for some time here. And if you have any doubt, then you can let me know by commenting to this live chat session. And I will try to answer your queries as much as possible. And then we will close this session. So let's wait for some time. If anyone has doubt. Okay, it seems like there are no doubts here. So we will close down. We will close our today's live session, and it was very interactive. And I hope you are understand it. So finally, we also provide online training, help in technical assignments. We also do freelance projects and industrial projects based on data science, Python, machine learning, embedded system, etc. So if you have any such requirement, you can let us know by contacting us through our website, which is www.jcbrolabs.org, or you can also mail us at info@jcbrolabs.org. Okay, so with this, we will close our today's session. Stay home, stay safe in this COVID time. Okay, thank you.